economic growth scenarios. So high, medium, and low. And then to assess what water productivity can do under various economic growth scenarios, we defined four different water productivity scenarios. A gray scenario, which things are slowing down, there's very little investment, and McKinsey, as I mentioned, they used this IEA World Energy Outlook scenarios. So they used the current scenario, the what's it called? I think the new policy. I don't even see the word here. But there's three scenarios out there from IEA. So they used those three scenarios and associated them with the different general water investment type scenarios or water productivity improvement scenarios. I think the other one is called new policy. And there's a fourth scenario that's not shown here, and it's called a low carbon scenario. Because the thinking is, the ideal is to be water use efficient and also to have a very low carbon footprint. But in that low carbon scenario that didn't fit on that slide, we use a higher share of biofuels. So that didn't necessarily actually improve water productivity that much. And also some of the other levers that were changed in terms of using non-renewable fuels didn't improve the industrial water use efficiency very much. So the results of that low carbon scenarios were almost the same as the business as usual scenario. So we usually didn't present that because there's so little difference. Okay. Yeah, this just shows a bit more detail if anyone is interested, what we actually changed in the parameters in the model. So for example, business as usual. So for residential, we have efficiency gain on consumption, some change in leakage reduction, the energy demand mix, etc. So this is the contribution from McKinsey. They told us, we have looked at all these parameters, and they do a lot of these studies for the domestic and industry sector. Actually, for domestic, they bought the data from the Global Water Intelligence Report. That's their market research tool for the private water sector. And basically, based on changes in these parameters, we got a final change in water use efficiency by country, from McKinsey. And then agriculture, we did ourselves. So we changed, yield growth, area expansion, basin efficiency, just to reflect here business as usual versus a blue water world. And then at the end of the day, we have basically a scenario matrix with low, medium, and high growth, and low, medium, high, and high water productivity improvement. And so the green that we need is the so-called low carbon scenario. And the medium high, whatever this graph, this is the business as usual scenario. And this just is an example of the results. And this is for the Brahmani River Basin, which is really a very small basin in India, but it's the only one where the results, you get so much variation in the results. So basically, if you have medium economic growth and business as usual, then we calculate that withdrawals over internal renewable supply are 25.8%. So you're in kind of this medium water stress, but not yet water scarce. But if out to 2050, you neglect water investments and efficiency improvements, and you still have medium growth actually, you have a small decline in, you could call it water security, or you have a small increase in water stress. However, if at the same time you have economic growth, then you pass the threshold of what we call water scarcity. At that point, we say that growth in this area is at risk because you really withdraw a very large amount of your water resources. And on the other hand, if you're very aggressive in improving your water use efficiency levels across all the sectors, domestic, industry, and domestic irrigation, you can get to a very low water stress level in that particular basin. So 16.2, where it's considered. In fact, I'm surprised it shouldn't even be green. I mean, you're even outside the moderate stress level at 16.2. So basically, what this shows is that, different levels of economic growth affect your water scarcity status. And at the same time, different levels of water productivity can affect your water scarcity status. And these are just some of the maps that show the same results at the global level. So we calculated for 2010 that water-scarce regions account for 36% of global population. So 36% of the global population live in water-scarce areas. So that means more than 40% water stress or withdrawals over internal renewable resources is more than 40%. And it's equivalent to 9.4 trillion US dollar. This is 2000 values. And also 39% of global grain production is produced there. So this is for 2010. And then if you go out to 2050 using that business as usual scenario, with basically historic current projected changes in productivity improvement, we do see that water scarcity does increase, and I think we probably all expected that. So slightly more than half of the population and almost half of global GDP and cereal production would be in these regions at risk to water stress. And also interesting side information is if we would have done these numbers at the national level, so those numbers have been calculated at the food producing level, so at 281 units. If you would have done it at the national level, the scarcity would be less, because as soon as you aggregate it, across a larger area, you have less water stress. So, and as I've mentioned, water scarcity is a more local phenomenon, but it does affect international food prices because we are trading cereals more than we trade water. And this shows again under those various scenarios, gray, low carbon, BAU and blue, rice, wheat and maize prices change. Generally under that high water productivity blue scenario we see a decline, so the brackets means we see a decline in rice prices compared to the BAU medium growth. And when we move towards the left, low carbon gray, we generally see an increase in food prices. And the low carbon generally has higher prices than the BAU because we have the biofuel production in there. So more biofuel production compared to the BAU scenario. But we also see shifts, obviously at different economic growth rates. We see also dietary shifts, with this rice becoming less interesting and wheat and maize increasing in relative desirability. So we also see those internal shifts happening at the same time as a result of economic growth. So it's kind of a mix of factors affecting the final food price outcomes here. Then, this was really the work, and then there's just some more slides that show, what are regional impacts, how much population, which region will likely be affected. And obviously, a very important thing is that China, especially India, India is already so extremely water scarce, and 60% of the food production relying on groundwater, which is not all of it is unsustainable, but quite a bit of it is unsustainable. So they really face quite serious water scarcity, and they're one of the largest food producers. So we really have to be trying to improve water use efficiency in that country. And if we look at climate change impacts, which we did not incorporate here, we didn't look at alternative scenarios, but it does include one climate change scenario, things would look even worse. So India is a problematic, and then we see China doing much better, but still also considerably water short as well. And the United States, another very large food producer, also quite water short. 2050 also reaching almost the 40% water scarcity level. And then, unsurprisingly, the semi-arid and arid countries tend to be the low-income countries, so you see more, they tend to hit that increased water scarcity level much faster. They also have higher population growth. And a lot of the Middle Eastern countries are not on the map because they're off the map. Egypt, Libya, etc. I mean, their water scarcity levels are much, much higher than the 120 cutoff point, so they're not on this one. Okay, then obviously if you compare, so if you move from business as usual to a gray water scenario with reduced investment in water productivity enhancing performance, you actually, you move 450 million people into this water scarcity, under the water scarcity threshold, and you have a total of 5.6 trillion GDP in addition at risk. But again, those are 2000 prices, so this is not, I think, actually economists don't like to present that, but anyway, the Veolia people they like GDP numbers. So you always have to add this is 2000 values. On the other hand, if you move to the right, so from business as usual, we moved, in the gray world. If you move to the blue world, on the other hand, we can actually move 1 billion people and 17 trillion GDP out of that water scarcity threshold, about 40%. So, it appears that changes in water productivity can make a significant impact. And importantly, again, it's both, water scarcity affects all countries and developing countries, even so developing countries have more problems to cope with it. But improved water use efficiency also benefits industrial countries, and that's again a point that was important for the water industry. Yeah, this is, for example, a slide we usually don't include, but it was important. This is Veolia North America. So even countries like the United States, of course, they are already facing critical water scarcity in the Western United States, and water productivity, also can make a difference. Can make a difference there. So if you move again from gray to BAU to blue, you can actually affect the final water scarcity index calculated here. And then on the other hand, as we have seen, India is very water scarce today, and it will be very difficult to make a difference even with very high improvements, very high investments in water productivity improvement. So they will always stay in the water scarce side of things. But obviously improvements can make, it will reduce their water scarcity indicator, but they'll never get out of the water scarcity. They will never get out of the threshold, given, at least not from water investments alone. They'll have to do something else. We've also tried to look at the impact on the number of malnourished children, and if it just, so this is just basically the food changes and calorie availability affects childhood malnutrition, and we have increased the access to safe water just under the blue scenario, because this is a so-called scenario that improves efficiency but also moves towards the MDG goals. And that alone, it's not huge, but it reduces malnutrition by 1 million children compared to business as usual. There's other factors that affect childhood malnutrition in this equation, especially female secondary education or female-to-male life expectancy. But there are much more. Especially female-to-male life expectancy is very difficult to affect, actually, to implement, to affect change. So, but just from water, you can get some. And here, again, so they're interested. So if we don't make changes in irrigation and we just improve domestic and industrial water use efficiency, will it make a difference? And it actually does. So we just improve domestic water productivity, but significantly. This is not small changes; those are significant changes, but deemed feasible by this by the industry. So this is their research mouthpiece of the numbers.